I'm Amudha. I'm working as an assistant professor at the Department of Computer Science and Engineering in Bharat Institute of Higher Education and Research. So today's session, we're going to see the subject artificial intelligence and the topic is common sense. So let's see what is today's agenda. So the first thing is we're going to see about what is common sense and what are the basic common senses we people know and what is the major real life issues that happens in the computer which cannot be implemented as a human common sense. So that is what we're going to see, that is computer and the ordinary real life issues and why computers cannot think about the world as any person. Okay, so all these things we're going to see. So next is what are the types of knowledges we have, and based on that, how we're gonna start or a sense whether it's a common sense, how we're gonna make a computer to think like a human. So how to teach common senses to a computer and building human common senses knowledge base, qualitative physics, and how we can build a computer program to do reasoning. So this is today's agenda. So we'll start from the basics of what is common sense and what is the basic sense and what is the real life issues that has been faced and why we cannot implement common sense to a computer and what are the types of knowledge is based upon the common sense and how we're gonna teach a computer to know about the common sense and how we're gonna build computer program to do such reasoning with the common sense. Okay, so we'll start. So basically, what is common sense? So we guys used to say, or even your friend say something right, you have to talk with some common sense. He doesn't have common sense. So what you say that doesn't get any meaning at all. Whatever you're trying to say should have some sense in that. So we people will always think. So let's see what are some basic common senses. Okay. See, we know often everyone knows, even the child knows it says always hot in summer. And when it is cold, one should wear warm clothes. So these are all some basic common senses we do not teach to anyone. So each human have it. Okay. So people cry when they are sad. Okay. And smile is a sign of happiness. And people like to spend time with their friends. And people do not like to get up early in the morning. So these are all the some basic common senses. And this common senses will vary from each individual. So though you guys are from the same family or you are from a big huge family, but each and every one will have the different unique common senses for individual person. Next, see mental skills that most people share. So this is a common sense, and you have the ability to analyze a situation. And these are all the basic things, and this is the definition for common senses. And the first person to talk about, or the first researcher to talk about the common senses, John McCarthy. So he was the first person to talk about common sense. So common sense is what people come to know after the process of going on the living world. So the thing, common sense is you just see to environment what is happening and every day you watch it and you learn by own. So when you grow, you'll be learning everything. So that is common sense is what people come to know in the process of growing and living in the world. Next, and third, common sense knowledge also includes some basic fact about the event and the effects and the facts about the knowledge, and it will always have a question how it obtained and the beliefs and desires. All these comes under the common sense knowledge. And the next is, so currently computer lack the common sense. See, in the artificial intelligence, the main intention is you're making a computer to think and act like a human. But where the computer lacks and where the artificial intelligence seems to be the challenging is making a computer to think like in the common senses. So when you try to implement a common sense to a computer, that is comes to be the big task for them. So that is what we're going to see it. Okay. And this is a place where computers lacks. So this is a only difference between the humans and the computer. Okay. Just consider this example. If you're giving a task to a computer, what it will do? It will always try to prove that or give a result in a faster rate, and in order to prove that it is not a computer, it is behaving like a human. And when you give the same task to human, what it will do? The same thing, it will give the output, and that will be proved that this is a human. The same thing. Okay. So whenever you try to give a task to computer, it will give you the result and it will be in the intention of proving that it is not a computer. It is trying to act like human. Okay. So the basic examples of common sense is, see, everyone knows that dropping the glass of water, the glass will break and water will spill on the podium. So this is one basic common sense. So this is tends to be the example for the common sense. We have lots of common sense example. So as of now, I'm just taking this example. So everyone knows the dropping of a glass of water, the glass will break and the water will spill on the podium. Next comes the major problem. What is that? So computers and ordinary real life issues. So here, obviously we know computer can do remarkable things. So when you make a computer to play chess, it will be the fastest one to complete the game on time, right? So see, computer programs can play chess at the level of best players, but the computer program cannot match with the capability or the way a 3-year child thinks. Okay, so you can train the computer to play a video game which much faster rate with a higher score, but you cannot train the computer program in how a 3-year old child, how it recognizes the objects or it can draw some simple conclusions about the ordinary life. So you cannot make that to the computer. Next, building machines can think the way any average person can as a distant reality. So what they're trying to say is when you try to build up a machine or when you try to build up a computer, so what happens is you cannot beat with a person's ability to think, right? Or the common sense is what a person has. So that comes to be the major task. So now, why computer cannot think about the world as any person? So as of now, we have come to a conclusion that only humans have a common senses and only they can possess the common sense. So we cannot train the system to have the common senses, and why so? Why it happens? That is the reason we're going to see. So the problem lies here is always the common senses have two types of basics of knowledge. Okay, the first one is specialist knowledge and the second is common sense knowledge. So what is specialist knowledge? So specialist knowledge is that, so mathematicians, scientists, and engineers possess, which means is in mathematicians, they'll derive some examples, they'll give some derivations, at the end they'll prove. What is scientific? The same. So they'll write all those theories, theorems and everything they'll prove. And engineers, all these are comes under specialist. So each one will have the special type of knowledge and the common senses. So that comes under specialist knowledge. Next is common sense knowledge. So basic, everyone has, even a 2-year child has, the one who's a 20-year-old have common sense, and that meets that age criteria. And so elder people of 60 plus or 70 plus people also have common senses according to their maturity level. So this is a common sense knowledge. So this is the problem where it lies. So we have two types of knowledge, on a specialist knowledge and the common sense knowledge. So this is the point where the computer lacks. And here is the problem why the computer cannot think and behave like humans. Okay. So now, so next is the reason is the need is to teach the computer to reason about the world. So you're training the computer to know about the common senses. So the researchers have not yet reached any such issues. See, you're just see, when you take a group of family, when a family, right, you have 8 members, each one have a common senses. So when you try to make a computer behave like that, so you have to feed all those people's actions, behaviors, or what they think, how they think, everything has to be fed into the machine. And when you try to question the machine, the reason is you will always get the reply in a way what you have fed in. If you try to face any situation other than this people common senses, the result will not be successful one. That comes to be the major problem. And here, so McCarthy is the first person to talk about the common senses, and now what the researcher has done is he has suggested some methods to use the represented knowledge, how is to use the logical ways to represent it. And by understanding the common senses capability in a particular area, so you can able to make it. Okay. So next is we're going to see about common sense knowledge and common sense reasoning. So we'll see one by one. So first is common sense knowledge. So the basic thing is what everyone knows, that is common sense knowledge. And common sense reasoning, ability to use common sense knowledge. So first is common sense knowledge is what everyone has. The second one is common sense reasoning, ability to use the knowledge. Okay. So we'll see detailed description of common sense knowledge. So what one can express as a fact using a rich ontology, which means that everyone will be having a common sense, and that tends to be the common sense knowledge. See here, when you ask a 3-year-old child, when you say something, don't touch the fire, because it doesn't know something. Right. So likewise, when you ask the same question when the child has been grown up, he'll say, I will not touch, it will hurt me. So likewise, based upon the age, so each one develop the common senses, but that has not been taught to anyone. Okay. So examples, see, the basic common senses as everyone has to know and everyone will be knowing it. So what are those? The examples are, so every person is younger than the person's mother. So obviously we know when you say that she is my mother, obviously the girl will be younger than her mother. And people do not like being repeatedly interrupted. So obviously we know, right? When someone tries to disturb you or interrupt you when you do a work, you will get irritated and you will not like it. And if you hold a knife by its blade, obviously you may cut by yourself. And if you drop a paper into a flame, obviously the paper will burn. And if you start getting hungry again after a few hours, you will eat a meal. So you will not wait, you will not think, you will not get any excuses from anyone, since you know that that is a common sense you possess on your own. And people go to parties to meet new people. Okay, so obvious, right? And people generally sleep at night. Okay. Next, common sense reasoning. So what we saw, common sense knowledge is what we possess the knowledge. Common sense reasoning is how to use that common sense you have. So what one builds as a reason method into his program, that is the common sense reasoning. So what are the such examples? So if you have a problem, so you will think of a past situation where you solve a similar problem. See, the best example for common sense reasoning is, see, suppose your friend is facing some issues, right? So what the person will think, so your friend will think, he'll think whether he has got the same problem in his life before, and he will think the way he has handled. So based on that, he will always try to solve the problem with the same method. Okay, the same thing. And if you take an action, so anticipate what might happen next. So when you do something, obviously you'll wait for the result and you will think what will happen next. If you fail at something, imagine how you might have done things differently. So obviously you guys will be knowing it. You guys are engineering students, and when you try to fail in a first internal assessment, so what you will do, then you will find the reasons, what are the reasons you have got failed, and you will try to change and implement, then you will get pass mark in the second internal assessment. So when you fail at something, and you will try to make out things in a different way. And if you observe an event, try to infer what prior event might have caused it. Okay. And see, the same thing is when you observe a situation or event, and you will be thinking, what might be the reason I'm standing here for? For example, if the class in charge make you guys to stand outside, might be you are late for the class. So what you will think? So next day, you will be thinking that you have to be on time for the class. That's the reason. And if you see an object and wonder if anyone knows it. So when you see an object, you're thinking whether they'll be knowing it or not. So this is a reasoning. See, common senses is what everyone possesses. Common sense reasoning it based on the common senses you're just thinking. That is the common sense reasoning. And if someone does something, ask yourself what's the person purpose was doing in that. Same, you question, right? If your friend does something and you feel that is of no use, so you'll think, we keep on asking why you are doing it. It is of no use. You'll be questioning it. So based on that, you are asking, you are reasoning it. Okay. So this is the examples of common sense reasoning. So far we have seen how to why the computer lacks with the common senses, and what are the major reason, and what is the difference between the computer and the human, and what point the computer lacks and the humans have got extra knowledge. The 2 points, that's common sense reasoning and common sense knowledge. This is a point we always ahead of a computer. So now, how to teach common sense to a computer? So the answer is there is no clear solution for this, and the researchers are trying it, and we'll see that one by one. So now, building a human common sense knowledge base. So building a human common sense knowledge base. So these are the two examples of common sense knowledge that have been developed or implemented in a computer. So the first is project CYC. See, as I said, so this topic is on common sense knowledge, and here we are trying to implement human common sense to a computer, and we have got the point that why we cannot do it, and what is the difference between the human and the computer. So now what we humans are trying to do is we are trying to implement the common sense into a computer. So that the researchers have tried with the two methods, that is project CYC, next is project OpenMind. So the project CYC is a common sense knowledge base which has been building for the past 20 years by the researchers, that is artificial intelligence researchers have started building this project CYC. So what they have done is they have collected 1.5 millions of common sense knowledges, and they have been grouped into it, and that has been fed into the computer. But the problem is still it is on the process, because every day everyone thinks in a different way. Everyone's common sense is different. So still they are gathering in. Okay, that is project CYC. Next is project OpenMind. So here in project OpenMind, this was started in the year 1999. And what they have done is they have gathered more than 7 lakhs of fact and the common senses from 15,000 people. And it was done in the MIT University in USA. So these are two projects in which the researchers are trying to implement the human common senses into a computer. Okay, next. So next comes the common sense reasoning. So as of now, we have seen all the common sense knowledge. So now reasoning. So what reasoning is, obviously you will be thinking. So how you make a computer to do a task, and how we want the computer to think like a human. That is what common sense is, reasoning. So in this way, we always go with the logical reasoning. So what are the logical reasonings we have seen in the previous unit is deductive, inductive, and inductive reasoning. So in all these cases, we'll be using the logical reasoning in order to implement the common sense reasoning. So what are things we have used? So predicate logic can represent knowledge about objects, facts, and rules. So the one thing using this logic reasoning is you can go with the predicate logic. So next is going with the frames. So frames which describes the everyday objects. The next is script. So scripts can describe typical sequence of events. So script means event. Suppose, so when you try to explain what happened, right? So when you start from a day, then you will come with the middle of the day, then you will come with the end of the day. That is a script. So continuous sequence of events, one after another has to be done. Next is non-monotonic logic support. Has to be done. So this comes under the common sense reasoning. Now, and apart from these common senses, there are some qualitative physics. See, obviously we people know. So like how this physical world works, right? So most people will not have know any basic theorems or law of physics or whatever thing, right? The older people, they will not know anything about the law of physics, but they will be saying everything, right? So some people or the farmers, they used to say by seeing the clouds, they say whether it will rain or it is sunny or humidity, everything they'll say, which means that they haven't read any law of physics or any degrees of any other climatic conditions in the previous, but they'll say, which means that that is their common sense. Okay. So here, so obviously, you know, when you throw a ball, it will bounce back. And then at the end, it will bounce with a lower height, then come to a rest. So this is everyone knows. So this is a qualitative physics, but so if you don't know any law or basics of physics, but obviously you will be possessing that common sense that when you bounce a ball, it will keep on bouncing it at the end, it will stop. The next. So can predict the projection of cricket ball and even you catch it. So when you guys play with the cricket, right, obviously you will see in which direction the ball comes and which direction the guy is going to hit, batsman going to hit, you will be knowing it, you will catch the ball. Right. So for these, you don't want to know any law of physics or law of motion or whatever thing. The next is obviously, you know, when you swing a pendulum, at the end, it comes in the middle position at rest. Okay. So these are all the qualitative physics. So why I am saying this now is, so this you guys don't want to learn. You have the some basic common senses. Now is how are we going to build a computer program to do such reasoning? So one questioning is, or one answer for this question is by governing the physical motion. Okay. So by governing the physical motion of each objects. So far we have seen with the what is common sense and what are the basic common senses and why it differs from computer and the human and how we can make computers behave like human or think or reason like a human is. The researchers have implemented with projects like Project CYC and Project Open Mind, and still it is under process. And next, in order to build a common sense reasoning system, so we have to know some basic things about qualitative physics. So with the help of the qualitative physics and the objects, only we going to build a computer program to do such type of reasoning. But see here, many people do not know the equations and they do not have exact numerical measure, but they can predict the physical situation. See, for the example I've said, when you go and ask a farmer, right, he will not say any climatic conditions. He can say whether it may rain or it may rain tomorrow, it may rain evening. But he has not possessed any degree or any other knowledge about the climates. Okay. So this is the reason. This people means that people always does not stick to the equation, but they may see or admire or observe from the environment. Okay. So here the researchers are forward with the two motivations like modeling the qualitative world and reasoning with qualitative information. We'll see what is modeling the qualitative world. So we have got some. So modeling the qualitative world. So here, so qualitative physics seeks to understand the physical process by building the models that may have the following entities. So see, in order to make a computer to think like a human, we have to know some certain things like modeling the qualitative world. So how to represent the world, how you going to model it, and that has to be fed into the computer. So how you will be doing it? So we have to know the basics of qualitative physics and what are the features. So we'll see what are the features. The first is variables. So what is variable? So a restricted set of values is called variable. So a restricted set of values are called variable. For example, if you're going to represent the temperature, so what are the variables you will use? You can say it is a frozen, or you can say it's between, you can say it is a boiling. Right, that is the way you use to represent the temperature. Next is quantity space. So small set of discrete values. So space, how you will say is full, empty, or you will mention in a meter, kilometer, all the things you will be saying there. Next, rate of change. So the things, how the changes happens, how you will represent that. So you can say that it is decreasing, it is increasing, or it is steady. So this is a way you will represent the rate of change. Next is expression. So you will be using the combinations of variables. So you will combine different types of variables. Next, equation. So assignment of expression to the variables. So what is an equation? It will contain both operands and the operators. You will call that to be the equations. So at the end you will assign the expression to the variables. Okay. And next is you have a set of variables whose values will change over time. So this is the modeling the qualitative world. So in the qualitative world, we have to know some entities like variables, quantity space, rate of change, an expression and equations. Okay. So next, see. So under this, how we build a computer program to do such reasoning is we have to go with the all the researchers have done move towards the modeling the quantitative world and reasoning with qualitative information. So as of now, we have seen with the modeling the qualitative world. So when you see the modeling the qualitative world, so what are the features or entities we have to know as variables, quantitative space, rate of change, expression and equation. All these things we have to know. Next, so this is the examples. See the examples for modeling the qualitative world. See, for example, I have taken with the qualitative algebra, I'm going to the addition. So here we're going to describe the volume of a glass. So we're going to describe the volume of a glass. So it can be empty, it is in between the glass or it is full of the glass. Okay. So now when two qualitative values are added together, then what happens when both the values are empty? Obviously the glass is empty. Suppose if in between empty and the between, obviously you'll say the water is in between and the half is empty. So you'll say between. And if it's empty plus full, obviously you'll say it is full. And between plus between, what you will say, the water can be the between or it is a full or it is overflown. And if it is between plus full, so what you will say, it is in between or it will overflows. So just you guys have to describe when you hold a glass with full of water or half water, what are the conditions can be done. That is what we're seeing as an example in the modeling the qualitative world. If it is both full and a full, then the result will be obviously full or it will overflow. Reasoning with the qualitative information. So the thing is, reasoning with qualitative information is often called as qualitative simulations. What is simulation? So when you are done with a particular certain task, that has to be occur in this different types of series. It should not be stopped in between. So here the basic idea is you construct a sequence of discrete episodes that occur as a qualitative variable. So you have to construct some discrete set of episodes that has to be occur continuously, like a sequence one after another that has to occur. And here the states have to be linked by some qualitative rules. Next, and the rules has to be applied to many objects at the same time, which means that has to be influenced with one another. So when you implement some rules on that sequence, that has to be reflected to the entire sequence to each and every part of the sequence. Next, ambiguity may arises. So what ambiguity arises in the sense, suppose if two types of meaning arises, if two situations occurs or you guys are confusing in that, so what you have to do is you have to split that in order to avoid the ambiguity. Next, a network of all possible states and the transition for a qualitative system is called as an envisionment. Means that mental images. So network of all possible states has to be done. Okay, these are all the basic ideas or steps for reasoning with qualitative information. So next, see, as of now we have seen how to build a computer program. For that we have seen with the modeling the qualitative world and reasoning with the qualitative information. Common sense ontology. So we have seen with the common sense is, now what are the common sense ontologies? So the basic concepts are that are fundamental to the common sense reasoning. So we'll see that should be a computer program that interacts with the real world must be able to reason about some certain things. So if you're making a computer to think like a human or behave or think common sense like a human, what you have to do? We have to program it. The computer has to know such things like time, space, and the material. So what is time? So basic notion of a time is event. Whenever this has happened, this has occurred, that will be the event. And the events occur during intervals over continuous spaces of time. And the interval has a start point and an end point, and it has a duration between them. And these intervals can be related to one another, like if this can represent in a is before or is after or is meet by or met by or it starts or it is started by, during, contains, ends, is ended by and equals. So we can build an axiom with intervals to describe the event in time. Okay. So this is how the time event and this is how the time will be represented. This is the common sense ontologies. The first one is the time. The second one is space. So space. The blocks world is a simple example of what we can model and describe the space. So normally, how when you represent object, when I say you guys to draw an object, what you will do, you will draw in a note on the paper. That is a two-dimensional representation, which means that you have an x and y coordinate. But here, what you have to do is, rather than using only these two coordinates, you have to go with the three-dimensional, like curves. You have to implement the three-dimensional thing when you try to implement with a computer. So you can also define relations like curves, lines, surfaces, planes, and volumes. And you can draw lines along across a perpendicular, etc. So this is how the common sense ontology of space is explained or described. Next is material. So time is over, space is over, the next is material. So describe the properties of material. So basic thing is, you cannot walk on a water. And if you knock a cup of coffee over, what happens? It will just spill over. Pour a full kettle into a cup, what happens? It will overflow. And you can squeeze a sponge, but not a brick. You know, right? You can squeeze a sponge, but you cannot squeeze a brick. But they all looks like the same way. So now, okay, so liquid. So liquid comes to be the interesting point, like a space. So how you can describe the properties of liquid is capacity, amount, and a full. So if it is capacity, it represents the amount of liquid. If it is a amount, the volume occupied by the liquid. And if it is a full, it amounts equals capacity. Other properties of material, you can say it as free. What do you mean by free? It is a completely unoccupied, and surround us, it is enclosed by very thin free space, and rigid is flexible, you can flex it. Take for example sand. So each thing varies. Okay, that's it. So as of now, today's session we have seen with